Hello friends, in this video let us solve previous year electronic science paper which was conducted by UGC NET. If you are visiting my channel for the first time, then do subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. So you need to solve 75 questions. Each question carries 2 marks. First question what they have given is, in an NPN transistor, the expression for avalanche multiplication factor is given by. This question is a part of ADC. They have given 4 expressions where VCB is connected to base voltage and B times of VCBO is maximum reverse biasing voltage which may be applied before breakdown between the collector and base terminals. We know that avalanche multiplication factor M is given by 1 divided by 1 minus of VCB divided by B times of VCBO whole power n, hence option D is going to follow. Second question, in a bipolar transistor, the stability factor for a fixed bias circuit is given by. We know that stability is expressed as S equals to 1 plus beta divided by 1 minus beta times of dou IB divided by dou IC. We know that in the case of fixed bias, dou IB divided by dou IC which is equals to 0. So I will be getting stability which is equals to 1 plus beta or beta plus 1. Hence option D is going to follow. Third question what they have given is, in a Wien bridge oscillator, the value of the frequency that can be calculated by the following expression. First expression what they have given is F0 equals to 1 divided by 2 pi RC. Second expression is similar to Hartley oscillator and Colpit oscillator. The third expression they have given F0 equals to 1 divided by 2 pi under root of L1 times of C1 plus C2. Fourth expression what they have given is 1 divided by 2 pi under root of R1 square plus R2 square into C1 square plus C2 square. We know that we are going to realize Wien bridge oscillator via Wheatstone bridge. Wheatstone bridge we are going to use plus op-amp we are going to use. So we are going to make use of resistors R1, R2, R3 and R4, but R1 and R3 will be the same, R2 and R4 will be the same. So the resistance you will be having R1 and R2, you will be having the capacitors that is C1 and C2. So the expression that is going to follow is option D is the correct answer. Right? Moving on to fourth question, what they have given is the value of magnetic field density is given by H equals to 28 sin x into AY vector. The value of current density is given by, we know that current density is given by dH divided by dx. So on differentiating 28 times of sin x, I will be getting 28 times of cos x and the vector should be along AZ. So the option that is going to follow is option A is the correct answer. Fifth question what they are given is a square coil which will be having a dimension of 0.2 meter cross 0.2 meter and carrying a current I equals to 3 amperes in a field of 10 Weber per meter square. You need to calculate the torque. We know that torque is given by BIA. What is the value of B? It is 10 Weber per meter square multiplied by what is the current, that is 3, multiplied by what is the area, that is 0.2 multiplied by 0.2 will be 0.04. Hence the answer that is going to follow is 1.2 Newton per meter, that is option D is going to follow. Sixth question what they are given is, for a transmission line which is terminated in a normalized impedance Zn, they have given VSWR which is equals to 2. The value of the normalized impedance is given by 1 by 2. Just reciprocate it. You will be getting the answer, that is option B is going to follow. Seventh question is based on electronic measurements. What they have given is a displacement transducer with a shaft of the total length is 3 cm they have given is applied as shown in the figure. The total resistance of the potentiometer is 5 kilo ohm. The total resistance what they have given is 5 kilo ohm. The input voltage what they have applied is 5 volts. When the wiper is at 0.9 with respect to 0, the value of the output voltage is given by. The question is similar to potentiometer. V out is given by what is the distance it has covered, 0.3 volt divided by what is the total length, it is 3, multiplied by what is the input voltage they have applied? It is 5 volts. So what you will be getting is 1.5 volts, nothing but option A is going to follow. If they are asking what is the equivalent resistance, so instead of writing 5 over here, you would have written 5 kilo ohms. Able to follow? Moving on to 8th question, they have given the symbol, you have to tell this symbol belongs to. We know that entire MOSFETs you can classify into enhancement MOSFET and depletion based MOSFET. In the case of enhancement MOSFET, you have to create the channel or you have to implant the channel. In the case of depletion based MOSFET, channel is already been implanted at the time of fabrication. So this enhancement and depletion is further classified into NMOS enhancement and NMOS depletion and PMOS enhancement and PMOS depletion. If you want to represent depletion based MOSFET, here you are going to do a shading part, right? So NMOS enhancement, how you are going to represent is, you will be having a gate terminal and you will be having a drain terminal, and this terminal let me assume to be source, and you will be having a fourth terminal that is bulk or substrate. That is bulk or substrate. The old direction will be towards the source, and in the case of bulk it will be away from the bulk, right? So this symbol is not getting matched. So this one is not the symbol for NMOS enhancement. Let me analyze for PMOS enhancement. You will be having 4 terminals. Let me call it as gate, and this one as source, and this one to be drain, and you will be having a fourth terminal that is bulk or substrate. In the case of PMOS, the current direction from source it will be like this, but for bulk it will be into. So this symbol is getting matched to P channel enhancement MOSFET, hence option B is going to follow. Now one more thing what I want to discuss is, in order to overcome body effect, what you are going to do is, this bulk we are going to connect to source. This bulk we are going to connect to source, and in the case of NMOS, drain will be at higher potential and source will be at lower potential. And in the case of PMOS, source will be at higher potential and drain will be at lower potential. These things you have to remember. 9th question, which of the following circuits come under the class of sequential logic circuits? First option what they are given is multiplexer. We know that multiplexer is a combination circuit which will be having 2 power n inputs and it will be having only one output. It will be having n select line. Based on n select line, which input should be driven to your output will be decided by your select lines. Or what your multiplexer will be doing is, it is going to serialize the parallel data. Able to follow? Next, let us talk about full adder. Full adder is a combination circuit which will be having or which will be accepting 3 inputs and it is going to generate sum and carry, right? So it is a combination circuit. So these two can't be the option. Next, let us talk about ROM. So in ROM, so to get familiar with ROM, let us talk about PROM, PAL and PLA. All these 3 things are memory based elements. So in the case of PROM, you can program OR gate, but AND gate is fixed. You can't program AND gate. But in the case of PAL, you can program AND gate. You can program AND gate, but OR gate you can't program. But in the case of PLA, you can program both OR gate as well as AND gate. So ROM is a combination circuit. Next, let us talk about RS latch. The first topic in the sequential circuits is latches. Then comes the flip-flop. So latch is a sequential circuit, hence option B is going to follow. 10th question what they have given is the Hamming code for 0110 using even parity. So this thing is very important. They are telling it is even parity. So you have to arrange the data stream with parity bits. So the first one will be parity bit, the next one will be again parity, the next one will be data bit, and next one will be parity bit, that is P4, next will be your data bit, that is D5, then D6, then D7. So you have to arrange the data bit, that is 0 1 1 0, right? So let me make use of 3 variable truth table. So the 3 variable truth table will be 0 0 0 to 1 1 1. Able to follow? So 1 0 0 1 0 1 1 1 0 1 1 1. When you are talking about first column, the first element and third element, fifth element and seventh element you are getting high. That means you have to check for odd places, right? So D3 bit is 0, D5 bit is 1, D7 bit is 0. So if I am considering D3, D5 and D7, you are getting odd ones, but you want even parity. So you have to make P1 as 1. Let us talk about P2. In the case of P2, you have to go for 2, 3, 6, 7 places. So third place, sixth place and seventh place, you are getting again odd number of ones. So you have to make it high. So in order to calculate for P4, you have to go for 4, 5, 6, 7. So go for 5, 6, 7. You are having even number of ones. So P4 should be 0. The data stream should be 1100 followed by 110. Nothing but option C is going to follow. 11th question, what they are given is phase lock loop is used for the detection of, directly I can tell, is used for the detection of FM signal. Hence option C is going to follow. 12th question, what they are given is the transistor amplifier has a measured SNR at the input of 10 and 5 at the output. They are telling us to calculate noise figure. We know that noise figure is expressed as signal to noise ratio at the input to the ratio of signal to noise ratio at the output. What is the SNR at the input? It is 10. What is this SNR at output? It is 5. So 10 divided by 5 will be 2. They are asking us to calculate in terms of dB. So noise figure in dB. How I can express it is 10 log 2. What is log 2 to the base 10? It is 0.3010. 0.3010, nothing but 3.01 dB. Approximately it is 3 dB. The option that is going to follow is option number B is going to follow. 13th question, what they are given is a signal varies from 20 Hz to 5 kHz is passed using pulse modulation scheme. Minimum sampling rate and number of channels that could be accommodated using TDM. Pulse duration, what they are given is, or the sample duration, what they are given is 10 microsecond. So this 20 Hz is very much far when compared to 5 kHz. So I can approximate to 0. Since all the options are very much far, so I can approximate this one to 0, right? So the minimum sampling frequency should be twice the highest frequency component of the message signal, that is 2 times of 5K, which is equals to 10 kHz. So I can eliminate this option A and option C, I can eliminate. Now what is the pulse duration they have given, or what is the sample duration they have given? They have given 10 micro. If I am converting into frequency, I will be getting 0.1 mega or 100 kilohertz. What is 100K divided by 10K is number of channels. So you will be getting 10 channels, nothing but 10 kilohertz comma 10. So option D is going to follow. Till now, if you are not like the video, please give it a big thumbs up. 14th question, what they are given is the term 1 divided by j omega on the log magnitude plot. So this question is based on Bode plot. So 1 divided by S. So you are going to replace S by j omega. So this 1 divided by j omega is for pole. And for 0 it is S, you are going to replace by j omega. This is for 0. So for a single pole, you are going to have a slope of minus 20 dB per decade. And for a 0, you will be having a slope of plus 20 dB per decade. If you are having n poles, at the time the slope will be minus 20 n times of dB per decade. If you are having n zeros, then the slope will be plus 20 times of n in dB per decade. Able to follow? So the option that is going to follow is option A is the correct one. 15th question, it is the limitation of RH criteria. What they have given is you will be having s power 6 coefficient, s power 5, s power 4, and in the case of s power 3 all the values you are getting 0. At that time what you have to do is you have to take the auxiliary equation, that is dA divided by ds, nothing but you have to differentiate this fourth row. So when I am going to differentiate this fourth row, I will be getting 2 times of s power 4, 2 times of s power 4 plus 12 times of s square plus 16 times of s power 0, nothing but 16, which is equals to 0. So I will be getting 8 times of s cube plus 24 times of s, which is equals to 0. If I am taking 8 as common, it is s cube plus 3s, which is equals to 0, or s cube plus 3s. That is option B is going to follow. Nothing but you are going to replace 0 by 1 and you are going to replace this 0 by 3. Able to follow? 16th question what they have given is Zener breakdown mechanism occurs in reverse biased PN junction. You will be having two breakdown when the diode is reverse biased. The first breakdown is Zener breakdown and the second one is avalanche breakdown. This Zener breakdown will take place when your diode, nothing but when your P and N heavily doped, at that time you will be getting this Zener breakdown. In the case of avalanche breakdown, it is lightly doped. And one more thing, for a Zener breakdown to take place, you require a huge value. For an avalanche breakdown to take place, you require a less value of the order of 50 volts. The third difference is one process will be there, that is impact ionization. Impact ionization, nothing but the electrons are undergoing huge electric field and the collision is going to take place, and that process is called as impact ionization. So first option what they have given is P and N are lightly doped. First option can't be. P and N are heavily doped, so option B is the correct one. Third option what they have given is are of silicon material only. No. Fourth option, P and N regions are equally doped, so third option and fourth option can't be. Directly you can eliminate, so option B is going to follow. 17th question what they have given is the operation of photodiode involves, directly you can tell it is photovoltaic effect, nothing but option B is the correct answer. 18th question what they have given is we have to calculate intrinsic standoff ratio in the case of UJT. We know that intrinsic standoff ratio eta is given by RB2 divided by RB1 plus RB2. What is RB1 plus RB2? Which is RBB. So you will be getting, what is the value of RB2? It is 4K divided by, what is the value of RBB? It is 10K. So I am getting intrinsic standoff ratio which is 0.4. But usually intrinsic standoff ratio is expressed in terms of percentage. So you have to multiply by 100. Always this intrinsic standoff ratio should be less than 1. So this is very important. 19th question what they have given is the triggered voltage of an SCR is close to 1 to 1.5 volts, nothing but a breakdown voltage, right? So in the case of SCR or a thyristor, you need to be very much familiar with respect to these two terms, that is forward blocking voltage. In order to reduce this forward blocking voltage, because it is of the order of thousands of volts, so in order to reduce it, what we are going to do is we are going to inject gate pulses. We are going to inject gate pulses. This SCR will be having 3 junctions, nothing but PN, right? So here you will be having one junction, here you will be having one junction, here you will be having one junction. So the symbol you are going to represent is like this. So this terminal is anode, this terminal is cathode, and this terminal is your gate pulse. You are going to inject the gate pulse. 20th question what they are given is the thyristor can be used as, this question is a part of power electronics, the thyristor can be used as a switch. Directly you can tell, so option C is the correct one. 21st question what they are given is Which of the following is an advantage to use optical fiber for data transmission? We know that for data transmission we can use twisted pair cable and we can use coaxial cable also. Even we can use OFC cable, nothing but optical fiber cable, or we can go for wireless one. But if you are going for optical fiber cable, resistance to data theft, yes. Fast data transmission rate, yes, because we are very much familiar with respect to ACT broadband or Airtel broadband whatsoever, the speed will be very much high. Low noise level, yes. So it is all of the above. So option D is the correct answer. 22nd question, the breakdown which is caused by cumulative multiplication of carriers through field induced impact ionization is avalanche diode. In the case of, you have studied about Zener breakdown and avalanche breakdown. In the case of avalanche breakdown, as I discussed, impact ionization is going to take place. So the option that is going to follow is option A is the correct one. 23rd question, transfer function of a system is necessary for the calculation of, first option what they are given is time constant, second option is the output for a given input, third option is the steady state gain, and fourth option is the order of a system. So you may get confused with respect to the time constant and steady state gain, but if I am opting best out of first option and third option, I need to go for third option only, because we are going to estimate for steady state response, nothing but steady state gain. That's why transfer function we are going to use. So the option that is going to follow is option C is the correct answer. 24th question, what they are told is, if one or more pairs of simple roots are located on imaginary axis on the S plane, but there are no roots in the right half of S plane, the response due to initial condition will be. Now look at over here, please concentrate. So Bode plot is applicable for a minimal system, and in the case of RH criteria and in the case of polar plot, in the case of Nyquist plot, in the case of root locus, we are very much concerned with respect to pole. We are not that much concentrated with respect to zeros. If all the poles are residing on the left half of S plane, you can damn sure stability will be there. If one of the pole is on the right half of S plane, then you can tell directly the system is an unstable system. But if you are having a simple pole, or a pair on a imaginary axis, then the system will be a marginally stable system. But what they are given is more pairs, nothing but multiple poles. If it is residing, then directly you can tell the system will be an unstable system, nothing but your response will be something like this. As time tends to infinity, your output is also increasing and it is tending to infinity. So option B is going to follow. If you are having a single pole over here or a pair over here, you will be getting this undamped sinusoidal oscillations. So these things are very, very important. You may get confused with respect to option B and option C. Right? 25th question, what they are given is 8255 programmable peripheral interface IC has got 24 input output lines in a following way. First option what they have given is port A will be having 8 input lines. This option can't be, because we know that port A will be bidirection, nothing but it is an IO, and even port B is also IO, nothing but it can act as input port or it can act as an output port. Port C, if I am talking, you can split this port C as port C upper and port C lower based on nibble. Upper 4 nibbles, 4 bits you are going to take, and lower 4 bits you are going to take. So based on this, you have to choose for the correct one. So first option can't be, and second option what they have given is port B with input lines, 8 input lines they have given. So option B also can't be, and port A with 8 input lines. So option C also can't be, and fourth option what they have given is port A with 8 lines as input output, yes. Port B with 8 lines as input output, yes. Port C is split into upper nibble and lower nibble, they are told. So this one is the correct answer. So the option that is going to follow is option D is the correct one. 26th question, what they have given is, they have given a C program. They have initialized I to 10. Nothing but the starting value of I is 10. Next, what they are performing is I equals to I plus nothing but 10 plus A. What is the ASCII value of A? It is 65. So I'll be getting I equals to 75. So I'll be getting I equals to 75. Nothing but option D is the correct answer. 27th question. You need to be very much familiar with respect to ternary operators in C programming. This instruction, how I can manipulate is, if x is greater than y, assign z equals to x. Else, assign z equals to y. So what is the value of x? It is 2. What is the value of y? It is 8. Is 2 greater than 8? No, right? So else part will be executed. That is nothing but z equals to y. What is the value of y? It is 8. The value that is taken by z is 8. Hence option B is going to follow. 28th question is based on C programming. They have given net equals to 0. Nothing but they have initialized net value as 0. First condition what they are checking is, if x is less than 50. What is the value of x? X value is 55. Is 55 less than 50? No, right? So this if statement will not be executed. Directly it will be terminated. So when the program is terminated, what is the value of net that is stored? The value of net that is stored is 0. So the option that is going to follow is option A is correct. Nothing but 29th question what they have given is, in 8253 programmable interval timer, in which mode the counting is neither enabled nor disabled. It is neither enabled nor disabled in mode 0 and mode 4. 30th question, in which mode of 8259A programmable interrupt controller all the interrupt requests are arranged in highest to lowest with IR0 as the highest and IR1 as the lowest. This question you answer in the comment section. 31st question what they have given is, a transmission line has the following characteristics. Which of the characteristics is true? You have to tell. So ZL is given by VF plus VR divided by IF plus IR is wrong. So VF minus VR divided by IF minus IR is correct, and propagation constant is given by under root of R plus J omega L into G plus J omega C. Impedance is given by this formula. So 2 and 3 is correct. Nothing but option B is going to follow. 32nd question, in an op-amp following characteristics are given. PSRR, nothing but power supply rejection ratio is 0. Yes. Thermal drift is defined as microvolts per degree centigrade. True. Fourth statement what they have given is, sleeve rate is defined in terms of volts per microsecond is also a true statement. Sleeve rate defines how fast your system or an op-amp can track the changes with respect to your input. So that is defined as sleeve rate. Nothing but first statement, third statement and fourth statement is correct. So option C is going to follow. 33rd question is based on digital electronics. First statement what they have given is, a flip-flop is used to store 1 bit of information is true. Raise around condition occurs in JK flip-flop when both the inputs are I. Nothing but when J equals to K equals to 1 is the correct statement. Why we are going to make use of JK means, in SR you will be having forbidden state. So in order to overcome that forbidden state, we are going for JK flip-flop. Third statement what they have given is, master slave flip-flop is used to store 2 bit of information is a false statement. First you will be having a master, the output of the master is given as slave, and in the next clock pulses you will be getting the actual output. So even the master slave flip-flop, JK flip-flop and even SR flip-flop, DT can store a single bit of information. We know that always Q is a complement of Q bar. Q should be a complement of Q bar. Fourth statement what they have given is a transparent latch consists of D flip-flop is a true statement. So 1, 2, 4 is correct, nothing but option C is going to follow. 34th question what they have given is an AM demodulator can be implemented using a diode followed by a low pass filter. This is nothing but envelope detector. This is nothing but envelope detector. So this is the simplest demodulator circuit that is available. So this statement is correct. And even a linear multiplier followed by band pass filter is also correct, but they have given band stop filter. So this fourth statement will be wrong. First and second statement anyway it is wrong. Statement 3 is only the correct statement. So option B is correct. 35th question what they have given is in a feedback control system a relative stability can be calculated using. First option what they have given is RH criteria. No. With the help of RH criteria, we are going to calculate absolute stability. With the help of Nyquist plot, polar plot and even in Bode plot, also with the help of root locus, we are going for a relative stability. So 2, 3, 4 is correct, nothing but option D is going to follow. So we should know the time domain technique, also we should know the frequency domain technique. So time domain techniques are RH criteria and root locus. Frequency domain techniques are Bode plot, polar plot and Nyquist plot. So these are all frequency domain techniques. In comparison to laser, 36th question, in comparison to LED, lasers has high emission frequency, yes. There is no need of tuning arrangement, yes. Wide spectral density is a false statement. Provision of confinement is true, nothing but it is highly coherent. So the statement that is going to follow is 1, 2, 4, nothing but option A is the correct statement. 37th question, the turn off time of an SCR can be reduced by quick withdrawal of the gate voltage, reducing lifetime by doping with gold, applying a negative voltage pulse to the gate. Quick withdrawal means you have to overcome the storage time. Quick withdrawal can't reduce the storage time. So this is not the feasible option. Reducing lifetime by doping with gold. This is something like Schottky diode. So in Schottky diode what we are going to do is we will be having metal semiconductor junction. So the main purpose is we have to reduce the storage time. How we are going to reduce is we are going to operate the diode in linear region and cutoff region. We will not make the diode to get into saturation region. This is how we are going to reduce the lifetime. Third option is applying a negative voltage pulse. Yes, with this method also you can follow, nothing but statement 2 and statement 3 is correct, nothing but option D is going to follow. 38th question what they are given is consider the following statements regarding a semiconductor. We know that at absolute 0 Kelvin your Fermi level is same as your intrinsic carrier level. You will be having conduction band over here and you will be having valence band over here. So at absolute 0 Kelvin you will be having Fermi level exactly in between conduction band and valence band. But in the case of N type, your Fermi level will be near to your conduction band. In the case of P type, your Fermi level will be near to your valence band. So these things are very, very important. So with this theory, let us solve this question. Acceptor level lies close to the valence band. Acceptor level lies close to the valence band is the statement what they have given. So this is a true statement. Donor level lies near the valence band. Donor level lies near the conduction band. So this statement is a false statement. Third statement what they have given is N-type semiconductor behaves as a conductor at 0 Kelvin. We know that at 0 Kelvin it will be behaving like an insulator. So the statement 3 is a false statement. What statement 4 says is in a P-type semiconductor it behaves as an insulator at 0 Kelvin. This is a true statement. Hence statement 1 and 4 is going to follow, nothing but option C is a correct choice. 39th question, transfer function for a control system is defined for linear system and time invariant system. We know that transfer function can be calculated for a block diagram technique, also for signal flow graph. In signal flow graph, we are going to make use of Mason's gain formula. This block diagram technique is used for linear system, also for non-linear system. But signal flow graph is applicable only for linear system. So the transfer function can be defined for linear system, also for time invariant system. So 1 and 3 is correct. So option A is going to follow. 40th question is bit tricky question. What they have given is tri-state buffer provide a reduction of current consumption in the circuit. Yes, tri-state buffers where we are going to use is, so let me consider you will be having one switch over here and you will be having a pull-up network and you will be having a pull-down network and you will be having one more switch over here, and here you are going to tap the output. So the entire circuit you are going to connect between VDD rail and ground rail. So let me consider the switches as S1 and S2. For normal operations, what we are going to do is we are going to close the switch, right? So this is a CMOS circuit. When you are turning off your laptop to hibernation mode or sleep mode, at that time the switches S1 and S2 is kept open. At that time your Vout node will not be drawing any power from VDD, or it will not be discharging to ground potential. So at that time your output will be neither 1 nor 0, it will be an high impedance state. Nothing but you will not be having any direct contact between input and output, nothing but isolation from input to output will be there. Yes. Reduction of current consumption in the circuit. Yes, this statement is also a true statement. High impedance during off state. Yes, high impedance will be there during off state. Low impedance will be there during on state. Yes, low impedance also will be there during on state. But precisely if I am choosing, I should not choose low impedance during on state, because we are very much focused with respect to off state. You can opt for the better statements. The better statements are reduction in current consumption. This is a best statement, and isolation from input to output. Even this statement is also a best statement. And high impedance during off state. Even this one is also a correct. So you can opt for option C, or you can opt for even option D also. But precisely if I am talking, the tri-state buffer means high impedance during off state and reduction of current in the consumption, right? So 1 and 3 is going to follow. So you can opt for option D. 41st question what they have given is, consider the following amplifiers. The correct sequence of the input impedance in increasing order. We know that for common base, input impedance is low. In the case of common emitter, input impedance is moderate. In the case of common collector, it is very much high. In the case of op-amp, we know that ideally input impedance is infinite, or practically if I am speaking, the input impedance will be of the order of mega ohms, which is a huge value. So if I am arranging in an increasing order, I should get common base as first. Next should be common emitter. So I can opt for option A. 42nd question what they are given is, the various components in a super heterodyne receiver is arranged as. We know that in the case of super heterodyne receiver, the first block will be your antenna, followed by you will be having RF tuning and amplifier, nothing but RF amplifier and tuning, followed by you will be having a mixer. You will be having a mixer. For this mixer, you are going to provide a local oscillator. This one you are going to do in order to remove the carrier components. Followed by you will be having IF amplifier. IF amplifier. So this block is followed by demodulator. This block is followed by demodulator. Followed by you will be having audio amplifier. So to boost the signal strength, we are going to make use of audio amplifier. In order to listen to the message, you are going to make use of loudspeaker. So demodulator block is nothing but AM detector. AM detector. So the blocks are given, you have to arrange in a proper order. So the first block will be RF amplifier. The second block will be mixer. The third block will be AM detector. The fourth one will be AM amplifier or audio amplifier. Right? So the suitable option that is going to follow is option A is the correct statement. 43rd question what they have given is, for a unity feedback system having a open loop transfer function g of s is given by this expression. They are telling what is the error constants, that is Kp, Kv and Ka. The type of a system is type 2. How I can define type is number of poles at origin. So we will be having type as 2. So we need to compare type with input. With respect to these two, you need to calculate for steady state error and the constants, that is error constants Kp, Kv and Ka. In the case of Kp, nothing but proportional error, you will be giving unit step input. In the case of Kv, nothing but velocity error, you will be giving a ramped input. In the case of Ka, you will be giving a parabolic input, right? So the type is 2. The system you will be having type as 2. Is 2 greater than 0? Nothing but if type is greater than input, steady state error equals to 0. If type is equals to input, steady state error equals to a constant, let me call it as K dash. If type is less than your input, then steady state error equals to infinite. How you are going to calculate the Ka means limit as s tends to 0, s square times of g of s. So this is how you are going to calculate this Ka. Kv, how you are going to calculate? Limit as s tends to 0, s into g of s. Kp, limit as s tends to 0, only g of s you are going to define. 44th question, you have to arrange in ascending order for the given logic families based on power delay product. So they have given 3 families, ECL, TTL and CMOS. We know that CMOS is the one which will be consuming very much less power. Nothing but static power dissipation is approximately equals to 0, but dynamic power dissipation will be there. The value of the dynamic power dissipation is FCL VDD square divided by 2. So in the case of CMOS, the power delay product, what do you mean by power delay product? It is a figure of merit. So in the case of CMOS, you will be getting power delay product as 0.7. Whereas in the case of TTL, it is up to 100. In the case of ECL, we know that ECL is the fastest logic. The power delay product will be ranging from 80 to 90. So based on this, if I am arranging, I should get 3, 1, 2. But none of the option is matching. But CMOS I need to consider first. So by default I have to opt for option D only. Able to follow? 45th question. Consider the following 4 common type of transistor. You have to arrange in an increasing order of the input impedance. We know that for a point contact resistance, input impedance is varying from 300 to 20 kilo ohms. In the case of bipolar junction transistor, the resistance will be tens of ohms. In the case of MOSFET, it will be in the order of mega ohms. In the case of JFET, the input impedance will be of the order of 10 power 10. Option C holds good. Nothing but first is bipolar junction transistor, followed by point contact transistor. Next one will be MOS field effect transistor. Next one will be JFET. 46th question what they have given is, if the various logic families are arranged in a ascending order of their fan out capabilities, the sequence will be, they have asked. We know that in the case of TTL, fan out is 10. In the case of DTL, fan out is approximately 4. In the case of ECL, fan out is 25. In the case of MOSFET, the fan out is 50. They have asked to arrange in an increasing order, so MOSFETs should be at last. The first one should be DTL, but none of the option is matching. The options framed by NET board is not proper, so by default I have to go for option A. 47th question, you have to arrange the frequency of the waves or rays in a descending order. So first one is UV. So in the case of UV, the frequency is of the order of 10 power 14 to 10 power 16. In the case of X-rays, the frequency is of the order of 10 power 16 to 10 power 19. In the case of visible, it is of the order of 770 tera. Tera means 10 power 12. In the case of UHF, ultra high frequency, it is of the order of 300 mega to 3 giga. 300 mega to 3 giga. So you have to arrange in a descending order. So the option that is going to follow is option C, holds good. Nothing but first should be X-rays and the last one should be your UHF, nothing but ultra high frequency. The next one will be UV followed by visible light. Able to follow? So the option that is going to follow is option number C is the correct statement. The structure of a decision table is divided into 4 parts. The first one, second one, third one, fourth one, they are telling. So the decision table for the first quadrant, in the first quadrant what you will be getting is, it is condition entry. It is condition entry. So fourth one should be condition entry. And in the second quadrant it should be condition stub. It is condition stub. And in the third quadrant it should be action stub. Action stub. And in the fourth quadrant it should be action entry. Action entry is third one and action stub is second one. So based on this, if I am matching, option C is the correct statement. 49th question, what they have given is, the parameters associated with time response of a control systems are, you have to arrange in an increasing order. Now look at over here, let me consider a second order system. First what you will be getting is, you will be getting a response which is something like this. This time is rise time. 50% of this time is delay time. The peak time over here is peak time. And the settling time, let me call up to 5 tau, this is called as settling time, that is TS. So they are telling us to arrange in a order from minimum time to the parameter which has got the maximum time, nothing but you have to arrange from minimum to maximum. So first should be delay time followed by rise time followed by peak time and it should be followed by settling time. So the option that is going to follow is option D is the correct statement. Option D holds good. 50th. In the assembly program, the following steps are to be followed. Find the sequence in which the program is to be written for 8085 microcontroller. So first thing what you are going to do is, in order to write the program, in order to start with the code segment, first thing what you have to do is, you have to declare a data segment, nothing but which is input, which one is output, whether you are in need of stack or you don't need any stack. At last you have to decide whether you have to enable the interrupts or you have to disable the interrupts. At last you have to terminate the program. So the termination of the program, this one should be at last. This one should be at last. First one should be initialization of variables. Second one should be initialization of stack. And the third one should be enable or disable the interrupts. At last you have to terminate the program. So the option that is going to follow is option B is correct. If you are making use of 8086 microprocessor, always you will be starting with dot model small. Always you will be starting with dot model small, followed by you will be declaring dot stack. You will be declaring dot stack followed by dot data. You are going to declare data variables. At last you will be writing this dot code. At last you will be writing with dot code. So based on this, if I am following, I'll be getting option C as the correct statement. There is no hard and fast rule that you have to declare first data segment, next stack segment, or first you have to declare the stack segment, next data segment. There is no hard and fast rule. But the only thing that you have to follow is you have to declare that stack segment. If you are not declaring, you will be getting a warning. 51st question, you have to match the following. Alpha of a transistor. We know that alpha is given by IC divided by IE. It's a current gain, so alpha is always less than 1. Beta of a transistor, we know it is always greater than 1. Beta is given by IC divided by IB. We know that IC is very much large when compared to IB. CMRR is defined as common mode rejection ratio. How I can define CMRR? It is defined as the ratio of differential gain to the common mode gain. If I want to express in terms of dB, means it is 20 log of AD divided by ACM. Power supply rejection ratio, how much you can reject the power fluctuation. So it should be 0. So for the 51st question, you will be getting option A as a correct statement. Able to follow? 52nd question. So magnetron is a pi mode, nothing but it will be operating in a pi mode. The pin diode is a detector. Pin diode is a detector. Klystron is for bunching and gun diode for low power oscillator. In the case of gun diode, it is going to undergo the negative resistance. It will be having negative resistance. Even tunnel diode will be also having the negative resistance. So you will be having the oscillations. So based on this, if I am writing, I will be getting option D as the correct choice. 53rd, match the following. First, what they have given is compounding squelch circuit or muting circuit pre-emphasis double conversion. On the list 2, they have given improving image rejection, variation of step size in quantization, muting the receiver, boosting of high modulating frequencies at the transmitter. Compounding means variation of step size in quantization. This is done in order to overcome slope overload distortion and granular distortion. Squelch circuit or muting circuit is for muting the receiver. Nothing but whenever you are not receiving the signal, no need to turn on the circuit is the question. If you are not using the laptop, let it be in an idle mode. So that is what you mean by muting circuit. So pre-emphasis is for boosting of higher frequency components. This is done to maintain signal to noise ratio greater than 1. Signal to noise ratio greater than 1. If signal to noise ratio is less than 1, demodulation is not possible. Double conversion is for improving image rejection. So based on this, if I am choosing, I will be getting option A as a correct statement. 54th question, match the following. 74150 is for 16:1 multiplexer. So this IC is for 16:1 multiplexer. 74152 is for 8:1 multiplexer. 74152 is for 8:1 multiplexer. 74153 is for dual 4:1 multiplexer. 74157 is for quad 2:1 multiplexer. I don't know why they have asked these questions. So we will be remembering only NAND gate IC, NOR gate IC. You have to remember IC numbers also. 55th question, what they have given is voltage control device, current control device, conductivity modulated device, negative conductance device. On the other side, they have given BJT, UJT, FET and impact. We know that FET is a voltage control device and BJT is a current control device. And in the case of UJT, you will be having this negative resistance. In the case of UJT, you will be having the negative resistance, and conductivity modulated device will be impact. Conductivity modulated will be impact. Option C holds good. 56th question, match the following. Optical fiber communication, mobile communication, digital communication, analog communication. On the other side, they have given frequency division multiplexing, time division multiplexing, code division multiplexing, wavelength division multiplexing. We know that in the case of optical fiber communication, wavelength division multiplexing we are going to use. In the case of mobile communication, we are going to make use of code division multiplexing. Nothing but a dedicated channel is kept for a particular user. For a digital communication, we are going to make use of TDM. We are going to make use of TDM. And for analog communication, we are going to make use of FDM. For analog communication, we are going to make use of FDM. So based on this, if I am choosing, I will be getting option B as a correct statement. 57th question. On the list 1, they have given Bode plot representation, Nyquist diagram, Nichols chart, root locus. On the other side, they have given not a frequency domain technique. Low frequency and high frequency characteristics of the transfer function can be determined. Decides the stability criteria, also known as polar plot. We know that root locus is a time domain technique. Root locus and RH criteria comes under time domain technique. So this Bode plot, Nyquist plot, polar plot, Nichols chart comes under frequency domain technique. So a root locus method is not a frequency domain technique. And this Nyquist diagram decides the stability criteria. For relative stability, we can go for root locus. For absolute stability, we need to go for RH criteria. Nichols chart is also called as polar plot. The extension of polar plot will be your Nyquist plot. And this Bode plot, we are going to make use of low frequency and high frequency characteristics of the transfer function can be determined. In the case of Bode plot, we are going for approximation, nothing but it is an approximation plot. Also, Bode plot is valid for minimal system. If poles are on the right of a phase plane, then the system will be an unstable system. Able to follow? So if all the poles and zeros are on the left of a phase plane, then the system is a minimal system. Able to follow? So this is very, very important. So based on this, if I am choosing, I will be getting option D as a correct statement. 58th question, what they have given is the following features of a microcontroller 8051. You have to choose which one is correct. It is having 4 kilobytes of ROM or EEPROM. This statement is correct. It is having 120 kilobytes of data memory. It is wrong. It will be having only 128 bytes of data memory. 4 programmable I/O ports. Yes, it will be having 4 programmable I/O ports. Nothing but port 0, port 1, port 2, port 3. Also, you can call it as port A, port B, port C, port D also. You will be having 3 16-bit timer or event counters. Yes, this is a true statement. So 1, 3, 4 is correct. Nothing but option C is going to follow. 59th question. Identify the peripheral device for their application. So this kind of questions are very much tricky questions. 8279. This 8279 is for keyboard and display interface. This 8155 is for timers and counters. 8253 is for additional input output lines to process. 8251, we know it is for serial communication. So the only option you will be very much familiar is 8251 is for serial communication. So D should be mapped to 1. So the option that is going to follow is option A is correct. 60th question is based on match the following: stability of control system, instability of control system, frequency response, damped oscillation. On the list 2, they have given oscillation in which amplitude decreases with time. So this is for damped oscillation. All roots of characteristic equation should lie on negative real part. If all the roots is lying on negative real part, then it is a stable system. If one of the root is lying on the right of a phase plane, then the system will become unstable. The steady state response is frequency response. The steady state response is frequency response. So based on this, if I am choosing, I'll be getting option B as correct statement. 61st to 70th question, the questions will be based on assertion and reasoning. If both the statements are correct and if reason is giving the proper explanation for assertion, then you have to opt for A. If reason is not giving the proper explanation for assertion, then you have to opt for B. If statement A is only correct and statement B is wrong, then you have to opt for option C. If statement B is correct, nothing but reason is correct but assertion is wrong, at that time you have to opt for D. What they have given is, in amplifier, it is easy to compare two powers on a logarithmic scale rather than on a linear scale. It is called decibel. Yes. How I can define decibel means, decibel is defined as n equals to 10 log of P2 by P1, where P2 is output power and P1 is input power. It is easy to compare and it is giving the proper explanation. So option A is correct for this. 62nd question, magnetron are not cross field devices. We know that magnetron are cross field devices. Second statement, what they are given is, they make use of electric and magnetic fields which are perpendicular to each other. This statement is correct. So assertion is wrong and reason is correct. Option D is correct. 63rd question, what they have given is, TDM can be employed to transmit channel having unequal bandwidth. Yes, if you are having unequal bandwidth, we can normalize it with the help of Nyquist sampling. If sampling theorem is strictly followed, any analog signal can be reconstructed back from the samples. Yes, at that time there is no overlapping of higher frequency components with low frequency components. So option A is correct for this. 64th question, they are telling NAND gate is a universal logic element. Yes, universal gates are NAND gate, NOR gate, multiplexer, demultiplexer, even encoders, decoders. ACE gate is also a universal gate. I have explicitly explained how demultiplexer will be acting like an universal gate. If you have not watched the video, links are given in the description. Please go through it. Any logic function can be realized using NAND gates alone. Yes, if you can able to realize basic gates, then directly you can tell NAND gate is an universal gate or a particular gate is a universal gate. Even this statement is also correct. So you have to opt for option A because reason is the correct explanation for assertion. 65th question, what they are given is, the stability of the control system can be determined from the location of roots of characteristic equation. Yes, based on the characteristic equation, that is 1 plus g of s into h of s, what we are going to do is, we are going to equate it to 0, nothing but we are going to make use of RH criteria. In the first column, if there is no sign change, then you can tell the system is a stable system. If there is at least one sign change, then you can directly tell it is an unstable system. If you are getting a row of 0, then it is a marginal stable system. What reason they are telling is, for stability, the root should lie on the left half of S plane. Even this statement is also correct. So A is going to follow. The intrinsic Fermi level of a semiconductor does not lie exactly at the middle of the energy gap, they are telling. So the intrinsic Fermi level will lie exactly on the middle of the semiconductor. So in the case of semiconductor, you will be having conduction band and you will be having this valence band. At 0 Kelvin, this Fermi level will be exactly between conduction band and valence band. Even this is intrinsic energy. So this statement is a false statement. The reason what they are telling is, the densities of the available states in valence band and conduction band of an intrinsic semiconductor is equal. Nothing but concentration of N type and P type will be the same. 67th question, what they have given is, the operating principle of laser is based on stimulated emission. Yes, this is a true statement. We know that lasers will be having a property, a stimulated emission, but LED is follows spontaneous emission. LEDs follow spontaneous emission. In coherent radiation, the emitted photons have same phase, same polarization and same direction with the incident photon. Yes, and reason is the correct explanation. So you'll be getting option A. 68th question. A microprocessor interfaced with inputs, output and other peripheral devices is also called as a microcomputer system and is capable of controlling the process. This is a true statement. The microprocessor is a device which processes the instruction. Even this statement is also correct. Nothing but you will be having a processor over here. For this processor, if you are connecting IO, if you are connecting memory, if you are connecting timers, if you are connecting interrupts, then this one will become a microcontroller. This one will become microcontroller. Able to follow? So the reason is not the correct explanation for assertion. So you will be getting option B. 69th question. In a control system design, the transfer function consists of both poles and zero. To make the system stable, the poles plotted on a Bode plot should be near to origin, they are telling. Yes, it should be near to origin. The zeros also should be near to origin. Yes, zeros also should be near to origin, but poles and zeros should be close to origin. This statement is correct and the explanation is also correct. So the option that is going to follow is A. 70th question. The P-channel enhancement MOSFET based transistor can be turned on prematurely. Nothing but high-headedly you can turn on. So this statement is a false statement. In the case of enhancement MOSFET, the channel will not be created. At the time of manufacture, channel will not be created. You have to enhance the channel or you have to create the channel. So assertion is wrong. What the reason they are telling is most contaminants in MOS fabrication are mobile positive charged ions and they get trapped between the gate and substrate in an N-channel MOSFET, whereas they are trapped on the other side of the substrate in the case of P-channel enhancement MOSFET they are telling. So reason is the correct one, but assertion is false. The option that is going to follow is D. My dear friends, if you have not yet subscribed to my channel, please subscribe to my channel. Also give a big thumbs up by liking this video. Question number 71 to 75, the questions are based on MOSFETs and JFETs. Pause the video and just go through it. 71st question, the point above the drain voltage when there is no increase in drain current in a JFET is called as first option breakdown point, second option pinch off point, third option knee point, fourth option critical point. We know that it is called as pinch off point, hence option B is going to follow. 72nd question, FET is disadvantage in comparison with BJT because of not for high input impedance, not for low noise, not for high gain bandwidth behavior. FET is a voltage control device, but BJT is a current control device. So BJT is a current control device, FET is a voltage control device, but they are telling FET is a current control device. So the option that is going to follow is option D is correct. 73rd question, for an N-channel silicon FET, alpha equals to 3 into 10 power minus 4 centimeter and they have given ND equals to 10 power 15 electron per centimeter cube. Find the pinch off voltage they have asking. We know that pinch off voltage Vp is given by Q times of Nd into alpha square divided by 2 epsilon. Make sure alpha they have given in terms of centimeter and Nd also they have given in terms of centimeter cube, but this one they have given in terms of meter square. So you need to convert properly. What is the value of Q? It is 1.6 into 10 power minus 19 into what is the value of Nd? Nd equals to 10 power 15 into what is the value of alpha? It is 3 into 10 power minus 4 the whole square whole divided by 2 times of what is epsilon? Epsilon equals to 12 epsilon naught. 12 into what is epsilon naught? It is 8.854 into 10 power minus 14. So upon solving, you will be getting 6.8 volts. That is option C is correct. 74th question, an FET is better chopper than BJT because it has first option high series on resistance, second option lower input current, third option higher input impedance, fourth option lower offset. So we know that FET is better chopper because of lower offset voltage. Statement A, B, C, all three things are interrelated. If I am telling it is having high input impedance, the system which is having high input impedance will draw low current and high series on resistance will be there. So A, B, C, each and everything is interrelated. So you have to go for option D. So the suitable option is option D. Last question. Friends, till now you have not yet subscribed to my channel, please subscribe to my channel. Don't forget to like the video, share this video with your friends. Last question. For an N-channel enhancement mode MOSFET, we know that in the case of linear region, current is given by IDS, which is equals to mu n Cox into W by L into VGS minus VTH into VDS minus VDS squared by 2. So this is in linear region where W by L ratio is called as aspect ratio. In the case of saturation region, IDS, nothing but IDS saturation, which is given by mu n Cox W by L into VGS minus VTH whole square whole divided by 2. In the saturation region, we are going to take VGS minus VTH as VDS. So this one, if you are substituting over here, you will be getting this expression. So the first statement what they have given is the drain current decreases with increase in drain current. This is something like a funny question. No need to opt for option A. Option B, what they are telling is decreases with a decrease in drain current. If I am decreasing the drain voltage, this quantity drastically reduces. At that time, the overall quantity will decrease. This one what they have given is a true statement. Drain current increases with increase in drain voltage. If I am increasing the drain voltage, this quantity is a dominating one. If I am assuming VGS as a low value, at that time IDS will be a lower value. The drain current decreases with decrease in gate voltage. If I am decreasing the gate voltage, IDS also decreases. So option D is a wrong statement. So the option that is going to follow is option B is correct. So friends, in this video I have discussed all 75 questions. I have discussed from fundamental point of view. So if you have followed with my lecture, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. Join my Telegram group to solve more and more MCQ questions. Thank you. All the best for your exams.